Okay, Assalamualaikum. Assalamualaikum and very good morning to all of you. Assalamualaikum and very good morning to all of you. So I would like to continue chapter 5. Chapter 5 part 1. Part 1. Line integral. Okay. So you will learn 5.1 line integral. Line integral of scalar fields. (5.2) line integral of vector fields. Independent path. Independent of its path, or we may call as conservation fields. And then 5.4 will be Green theorem. Okay. So line integral is the integral over curves into or 3D space. Line integral is the integrals over curve in 2 or 3D space. Okay. One of the most important is to calculate the work done by certain forces. So theorem 1. Suppose phi, function of x, y, z, is the continuous over a smooth curve C. And S is the arc length. Measured along C. If the equation of the curve is RT equals to, this is in vector form, XTI plus YTJ plus ZTK. Okay. ZTK. Then integral curve over C ds will be integration under curve C, function of xt, yt, zt times with the ds dt. ds will be the magnitude of RT times with the dt. Okay. So this can be represented as C, the phi function of xt, yt and zt times with the magnitude x prime t squared plus y prime t squared t squared plus z prime t squared. Well, I just can put as z prime square times with dt. Okay, note that the length of the curve C, the length of the curve C is the integration ds, 1 ds. Okay, you see example 1. Evaluate the line integral x plus y plus z ds, where it's given by x equals to 3 cos t, y equals to 3 sin t, z equals to 40. Your t is from 0 to 2 pi. Okay. So solution. So to find this line integral, you have to change this ds to the magnitude of dr dt times with the dt. Okay, so you have to find first ds, that is the magnitude of r prime t dt. Then your r prime t will be the x prime, sorry, carry in the vector form, x prime, y prime, z prime. Okay. Okay. So xt equals to 3 cos t. Okay. Then x prime will be x prime t, or just x prime, negative 3 sin t. Yt will be 3 sin t, so y prime t will be 3 cos t. Okay, differentiate sign will be cos, differentiate cos will be sine. And then your zt is 40, and then z prime t will be 4. Okay, so next you have to find the ds. Okay, here the ds. ds will be square root of x prime square, y prime square, z prime square. Okay, so substitute this, then you will get 5. We have dt here. Okay, actually this is a ds dt, so we just bring the dt from the left to right hand side, or times dt for both sides. Hence the line integral becomes integration under the curve C, x plus y plus z ds will be 0 to 2 pi. This is given here. Okay, 0 to 2 pi. Your x, y, and z, right? Your x, y, and z, your xt, yt, and zt is 3 cos t plus 3 sin t plus 4t and then again your ds, okay, your ds will be 5 dt, 5 dt. Okay, so don't get confused, please remember the formula and understand it. Okay. Okay, so if you solve this, I leave it to you because you have learned in engineering mathematics 1. So we have 40 pi squared. Okay, 40 pi squared. Okay, example 2. Find the length of arc. Find the length of arc of the curve C defined as xt equals to 2 cos 2t, yt will be 2 sin 2t, z is 3t, and your t is between 0 to 1. So again it's the same. Remember, length of arc, I already told you, length of the arc will be integration of 1 ds. Integration of 1 ds. This is length of arc, and this ds will be magnitude of r prime t times v dt. Okay, so as usual, you have to find this magnitude of r prime dt, so you have to differentiate. Ds will be square root of x prime t squared plus y prime t squared z prime t squared, and you will get 5 dt. Check. Okay, differentiate one by one. Okay, differentiate cos will be sine, and differentiate inside will be negative 4 sine 2t. This one differentiate, you will get 4 cos 2t squared, and this, if you differentiate this, you will get 3. So 3 will be 3 squared. Okay. And then your s, let's say I put just s here, is the integration from 0 to 1 ds, 0 to 1 5 dt, and this is just 5. Okay. Okay, next theorem. Theorem 2. Parametric equation for a line. Parametric equations for a line. The parametric equation for a line through P. Let's say we have P x naught, y naught, z naught. Parallel, I just put this sign, shows that parallel to V, vector V, that is A, B, C, or you can write as AI plus BJ plus CK, R, x equals to x naught. You have learned in matriculation or STPM, plus BT, Z equals to Z naught plus CT. Line for parametric equation is a line of the segment connecting of 2 points. Okay, so see example. Okay, evaluate 3x plus 2y plus z ds, where C is the line segment from 0, 0, 0 to 1, 2, 3. So you have a line segment, which means you have two lines. Let's say I put here 0, 0, 0, and then I denote as x0, y0, z0, z0 I mean, and then another point is 1 to 3. I label as x1, y1, z1. Okay, and automatic this is r at t0 and this is r at t1. Okay, let me write again, r at t1. Okay, okay, so say x from this formula, so x y z is equals to x naught, I just rewrite back, y naught z naught plus v the parallel vector t. Okay, okay, then I have x y z equals to x naught, y naught, z naught, and this v can be determined by subtracting rt1 with rt naught. x1, y1, z1 minus with x naught, y naught, z naught. This is the parallel vector times with t. So your x, y, z will be the 0, 0, 0 plus 1, 2, 3, t. Okay, so now you have to choose your limit t. Okay, so to find this, your x, now your x is equals to t. We let for limit t, let choose x equals to t. We choose x equals to t, so your x naught will be the t naught. Your x1 will be t1, t naught will be 0, t1 equals to 1. Okay, x naught will be 0, x1 will be 1, x naught, t naught. When x equals to t, x naught equals to t naught, 0 equals to t naught, x1 equals to t1, 1 equals to t1. Okay, okay, from here also you can know that x equals to t, y equals to 2t, z equals to 3t. So the line segment C is defined as x equals to t, I'm just repeating, y equals to 2t, z equals to 3t, and then your t is between 0 to 1. Okay, 0 to 1. So from here, x prime t will be 1, y prime t will be 2, z prime t will be 3. Okay, okay, again let's say I choose x equals to 2t. So x naught equals to 2t naught. So your x naught is 0, y naught 0, z naught 0. So 0 equals to 2t naught. So your t naught will be 0. Okay, x1 will be 2t1, x2 2t2, x3 2t3, and so on. So x1 will be 1, one, 2, t1, sorry, I think I have made a mistake. X1, x equals to t from here, y equals to 2t. So y naught will be 2t naught. So y naught is 0. This is y1, x1, y1, z1, x naught, y naught, z naught, x naught, y naught, z naught, x1, y1, z1. So y naught will be 0 to t naught. So t naught will be 0. So y1 will be 2t1, y2 will be 2t2, y3 will be 2t3. So y1 is 2 from here. So 2t1, your t1 will be 1. So your integration will be from t0 to t1, which is 0 to 1. Okay. So I continue to find the integral, line integral. So the line integral becomes 0 to 1, 3x plus 2y plus z ds, which is equals to 1, and this will be 3t, your x equals to t, y will be 2t, so that is 4t, plus z equals to 3t. Your ds will be the square root of x prime squared, y prime squared, z prime squared dt. So this is equals to 0 to 1, 3t plus 4t plus 3t. This is square root 14 dt. Then you integrate this, you will get 5 sec 14. So please check. Okay. Okay. Next, theorem 3. Okay, theorem 3. If C consists of n piecewise smooth curve, C1, C2 until Cn, then your line integral, say function z ds will be C1 phi ds plus C2 phi ds plus this plus, and then Cn phi ds. Okay. Okay, that's example 4. Okay. Okay, example 4. If C is a line, C is the line segment from 0, 0, 0 to 1 to negative 3, then to negative 1, negative 2, 1. So evaluate integral xy minus z ds, where s is the arc length measured along C. So we have to think that we have 0, 0, 0, and then we have 1, 2, negative 3, and then we have 1, negative 1, negative 2, 1. So we have R1 here, and then from this you have R2, and then each of them will get C. Okay, the curve C consists of piecewise smooth function, that is C1 and C2, where C1 is the line segment from 0, 0, 0 to 1 to negative 3. So here we'll produce C1. Okay, and then C2 will be from 1 to negative 3 to negative 1, negative 2, 1, C2. Okay, remember this. You have C1 and then you have C2. Okay, so first, the solution for line integral on C1. On C1. Okay, the calculation of the line integral on C1. So remember, from this point, these 2 points, you can find the parametric equations. So from here you will get x equals to t. Remember the formula: x equals to x naught plus at, y equals to y naught plus bt, let's say, z equals to z naught plus ct, and abc is the parallel line. So this can be found by minus from the second and the first. Okay, then x equals t, y equals to 2t, z equals to negative 3t, and then your t is between 0 to 1. Okay, let's say you choose x equals to t, right? So your x naught is 0. This is x naught, y naught, z naught, x1, y1, z1. So x naught equals to y naught, x naught equals to t naught, x1 equals to t1. So x naught 0, t naught also 0. Okay, your x1 equals to 1, t1 equals to 1. So your integration should be 0 to 1. So I just skip some steps because I already taught you before. Okay, so from here, so the parametric equation of C1 is x equals to t, y equals to 2t, z equals to negative t3, 3t from 0 to 1. The t is between 0 to 1, from which the equation, now your r is ti plus 2tj plus negative 3 tk. So I can omit this. Then your ds is the magnitude of r dr dt times with dt. Okay, 1 plus 4 plus 1 plus 4 plus 9. Okay, that is square root 14 dt. So the line integral as given in the question will be 0 to 1, and then your x is t, y is 2t, minus z is negative t3, negative 3t, okay, times with square root 14 dt. So if you find this, you will get 1 over 6 13 square root 14 plus 60. Okay, we can use in point form also, but I would suggest you, recommend you to write in a fraction form because it is accurate. Okay, so that is an exercise you can do by your own. So next I will move to 5.2, line integral of vector field. So before this is scalar field, now is the vector field. Okay, so scalar integral f ds, okay, or phi ds. So this s refer to the displacement for vector integral f dot dr or phi dot dr, where the f is a vector, okay, the dr will be the vector displacement. Okay, okay, so let f fx yz equals to f1 function of fx yz plus f2 function of xyz j plus f3 k. Okay, that is also a function of xyz. So since r, vector r is xi plus yj plus zk, okay, I just put in a component form. Okay, then your dr will be dx, dr dt will be dx dt I plus dy dtj plus dz dt k. Okay, okay, so hence we will have line integral of a vector field will be f dot with dr is the integration of f1, okay, f2 comma f3 dot with d okay x over d t I plus dy dtj plus dz dtk times with dt. Okay, so I think there's no dt here. So we just eliminate this to make any confusion, without making any confusion. So we have dz here, k, this is I. Okay, so you can write this as f1 dx plus f2 dy plus f3 dz, because this is a dot product, so we left like this. Okay, so if f the force field, then the line integral represents the amount of work done by f in moving particle along the curve. If f is a force field, then the line integral represents the amount of work done by f in moving a particle along the curve. Okay, so we see example 5. So this is 5.2.1, line integral around open curves. Okay, so example 5, evaluate the line integral f dot dr, which is total work done, where the f function of xyz is the x squared y, 3xz squared j, 2yz k, and c is given by RT equals to t 3t squared 2 and 2. Okay, where the t is between 0 to 1. So first find dr. Your dr will be the x prime, y prime, z prime dt. Okay, so di dr equals to dx I plus dyj plus dzk, so which is equals to 160, 0, right? Okay, your x. Okay, then you can substitute the formula. This formula. So your integral f dr will be integration of c x squared y f1, this is, so I should write f1 here. This is f1, this is f2, and this is f3. So f1 will be x squared y times with 1 dx, this is dx, plus 3x z squared dy plus 2yz dz. Okay, f1 dx, f2 dy, f3 dz. Then okay, so your dx is 1, dy will be 60, dz will be 0. Okay, I mean dx dt will be 1, dy dt will be 6, dz dt will be 0. So your integration from 0 to 1 will be t squared, 3t squared times 1 is 3t 2 squared 60 0 dt. Okay, plus. So integrate this. I just leave it to you. This is 60, should be 60. Should be 60. So you will get 1, 2, 3, or 5. So please check. Okay, example 6. Example 6, evaluate integration of f dot dr, total work done, where the f is x squared I yj plus xz minus k, minus y k. C is the line segment 1 1 1 2 1 2 4. So again, this is a line segment. You should find a line in the space. So v, the parallel vector, will be 1 minus 1, 2 minus 1, 2 minus 1, and 4 minus 1. This is 1, 2, 4. Okay, so this is nothing but 0, 1, 3. So as you know, x equals to x naught plus at, y naught plus bt, z equals to z naught plus ct. So your x naught, y naught, z naught is 1 1 1, and then your a b c, the parallel vector v, is 0 1 3, or you can just put v, it's okay, v. So your x is 1, your y is y naught plus bt, that is 1 plus t, z equals to 1 plus 3t. Okay, so to find the limit, your t, okay, from 2 to t equals to y minus 1. So your t naught equals to y naught minus 1, t1 equals to y1 minus 1, t2 equals to y2 minus 1. I just rearrange it from here, and then your y naught is 1, so 1 minus 1 will be 0. So t1 y1 minus 1. So your y1 is, where is your y1? X naught, y naught, z naught. Your y1, it is here. So let's say I put x naught, y naught, t naught, x1, y1, z1. So your y1 is 2. 2 minus 1. So your t is between 0 to 1. Okay, so your RT is I plus 1 plus t, j plus 3k. Sorry, 1 plus 3k. 1 plus 3k. Sorry, 1 plus 3tk. Okay, just do from here. Okay, So because the RT is not given, you need, and then you have to find. So then you have to find the dr, because the formula of integral, scalar integral for vector integral, so you have f dot dr. Okay, so your dr will be differentiation, you get 0, differentiate 1 will be 0, and then you will get 1, t 1 0, t is 1, and then this is 3. Okay, so your integration will be where is your f? Oh, this is your f, f dr, f1, this is f1, f2, and f3k. So this integration of c x squared I plus yj plus xz minus yk dot with dx I dyj plus dzk. Okay, so how about dx? Right, your dx. So your dx is 0, right? Dx. So this is same as your dx. Okay, dy dz. Okay, so this will be 0 to 1, 1 squared times 0, 1 plus t times with 1, and then you have 1 plus 3t minus 1 plus t times with 3. Okay, because your dz is 3. And then if you solve this, you will get 9 over 2. So please check. Okay. Okay, example 7 will be your practice. And then I go for 5.2.2 line integral around closed curve. Okay. Okay. So find example 8. Example 8. Find f dot dr. Total work done. If the f is x cube, xj and 0, and C is the closed loop, is a closed loop formed by semicircle y equals to square root 1 minus x squared from 1 0 to negative 1 0, and the line segment from negative 1 0 to 1 0. So try to sketch first. So it is 2D xy, and semicircle is negative 1 to 1 1 0 here, and negative 1 0, and the line from negative 1 0 to 1 0. So it is anti-clockwise, that is positively oriented from 1 0 to negative 1 0, and another one is negative 1 to 1. So it is anti-clockwise, or we call positively oriented. So you have to think that we have 2C now. From here to here, C1. Okay. Okay. C1. Okay. The line segment will be C2. So you have to find this C. So your integration f dot dr will be C1. It is closed because there is no open vector, dr plus C2 f dot dr. Okay. So first, along C1 you have f dot dr will be C1 x cube dx plus x dy. Okay. So your circle now is y equals to square root 1 minus x squared. Okay. And this is same as x squared plus y squared equals to 1. So if you found something like this, you have to use the x equals to cos t, y equals to sin t, because it is involving the circle. So for sure this is anti-clockwise, this is 0, and this is pi. So your t will be from 0 to pi. Okay, this is just a common sense. So your dx will be, x is cos t, your dx will be negative sin t, y is sin t, and your dy will be cos t. Actually you have to dt, put dt here. Okay. So integration C1 f dr will be 0 to pi, okay, f1 times v dx. Okay, this is x cube will be cos cube t times with dx. So your dx will be negative sin t dt plus x dy. So your x will be again cos t, and your dy is another cos t dt. Okay, I should put this. Okay, then you will get, so try to do this. Maybe you have to use some formula involving the identities. So you will get, and using the substitution method, you will get pi over 2. Okay, so for C2 FDR, okay, this is from negative 1 0 to 1 0. Okay, the line segment here, second one, C2, along C2, right? Along C2. So your V is 1 minus 1, which is the difference. and 0 minus 0. Okay, so this is 2, 0. So now your x will be -1 plus 2t. Your y is 0. So dx will be 2 dt. dy will be again 0. So x equals to -1 plus 2t. Your x naught will be -1 plus 2t naught. Your t naught will be your x naught. You have 2 points, -1. I just say this is x naught, and y naught, x1, y1. Okay, so your t naught will be, okay, let's say I put x naught is -1. So -1 equals to -1 plus 2t naught. So 2t naught will be 2, t naught will be 1. Okay, sorry, this is 2, x naught will be -1. This is -1 plus 2t. Let me check again. This is -1 plus 2t. So x naught will be -1 plus 2t naught. Okay, your t naught will be 2t naught will be x naught plus 1. So t naught will be x naught plus 1 over 2. Your x naught equals to -1. So this is 0. Okay, so another one is t1 equals to x1 plus 1 over 2. So x1 is 1. So 1 plus 1 over 2, this is 1. So your t will be between 0 to 1. Okay, so we already find the limit. We already have all the information. So just plug into the formula, that is C2 FDR along C2. Okay, so FDR will be C2 x cube dx plus the same thing dy. So 0, 1, -1 plus 2t cube 2 dt plus 0 dt. So if you solve this, you will get 0. So the total work done, okay, by a force can be written as C1 F dot dr plus C2 F dot dr. You will get pi over 2 plus 0, that is pi over 2. Okay. Okay.